Before working on your vehicle, always raise and secure it to the frame with properly rated jack stands or automotive hoist according to the vehicle manufacturer's recommendations and procedures. For safety, the installer and all vehicle drivers must review the complete set of print version installation instructions and heed all the included cautions and warnings. The Ford 9-inch is a popular third member among race enthusiasts. This is a step-by-step instructional how to prepare and build a Ford 9-inch third member so it runs smooth and has a long life. For more in-depth explanations and breakdowns for this build, check out these videos linked on screen. Main caps are line bored, meaning that each cap needs to install in the same side and orientation as it was originally machined. Mark side caps with unique marks that match their position and duplicate these marks on the third member. Punch marks or paint can be used. Loosen the side adjuster clip screws, then rotate the lock clips out of the way. Unbolt and remove the main caps and the side adjusters. The adjusters are machined identically, so they are interchangeable for installation on either side. The pilot bearing can be installed in either direction. Use an appropriate sized driver to drive or press the pilot bearing into the third member. Once fully seated, drive the retainer clip into the third member to secure the pilot bearing in place. Keep driving until the clip is flush against the bearing and all the clip side tabs are engaged into the bore. Next, prep the differential case. Drive or press the roller and cage side of the carrier bearings facing outward onto both of the differential case journals. Do not use a flat driver. Since the differential case journal is longer than the overall bearing thickness, the bearing would not seat completely. Use a driver that only contacts the bearing's inner race and leaves enough room for the journals to protrude past the side bearings when they are fully seated. An old carrier bearing can be stripped down and sanded or ground out slightly if you do not already have a good driver adapter. For best fit, and to minimize interference in the fit, lightly file the flat face of both the gear and the differential case seating. This will eliminate any burrs or debris. Then wipe the surfaces and work area clean. Use a quality thread locking compound on the ring gear bolt threads to prevent them from backing off over time. Lightly fit the ring gear in place and secure the ring gear bolts finger tight. The ring gear has to seat evenly and perfectly flat. One of the ways to seat the ring gear to the differential case while reducing the risk of stripping ring gear bolts is to use a press. Use wood to protect the ring gear from chipping during the pressing process. Make sure the adapter between the press and differential unit places pressure on the differential case journal and is not contacting the carrier bearing. Torque for the ring gear bolts should be 65 foot-pounds. Like the ring gear face, lightly remove burrs and debris from the pinion stem using emery cloth or ultrafine sandpaper. The inner pinion bearing is placed onto the pinion stem with the roller and cage side of the bearing facing outward, away from the pinion head. Use a good, moderately soft metal pipe that has an inner diameter that contacts the inner race of the pinion bearing without touching the rollers or cage and is a couple of inches longer than the pinion. The diameter of the press pipe should also have a slightly larger inner diameter than pinion stem base to prevent accidentally getting it stuck onto the pinion shaft during this step. Press or drive the inner pinion bearing until it is fully seated on the pinion head base. A popular and stronger optional pinion support for the Ford 9-inch is a Daytona style. The Daytona style uses an inner pinion bearing and race that is larger than stock style. Stock pinion supports more commonly use the same sized inner and outer bearings and races. press in the inner and outer bearing races into the pinion support without lubrication and with the receiving sides outward. Once the races are fully seated into the pinion support, apply some gear oil to the rollers and set the outer bearing into the outer race. The pinion seal has a small tension spring in the back side of the seal's inner lip. Place the seal spring side down into the pinion support, then press or drive the seal in place over the outer bearing. Make sure the pinion seal spring does not knock loose, or it will cause damaging internal debris and greatly reduce its sealing capacity. There are a couple of methods for setting pinion bearing preload when installing the pinion gear into the pinion support. The most common factory method is to use a crush sleeve, which collapses during the pinion nut torquing. Our preferred method is a solid spacer, which uses a metal spacer in addition to thin shims to adjust to a precise thickness. When using a crush sleeve, it is positioned onto the pinion shaft and seats on the inner pinion bearing. The pinion support gets placed over the pinion gear. Place the yoke onto the pinion gear and thread on the pinion nut. A yoke holding tool or similar tool can greatly help hold the yoke in place during this step. To begin setting preload with the crush sleeve method, secure the pinion support into a vise, making sure the pinion and yoke are able to be rotated without obstructions. Use a breaker bar to torque the pinion nut until sufficient bearing preload is achieved. When the pinion and yoke can be spun easily by hand but stops quickly, the preload is probably close and should be measured. Small additional pinion nut torque adjustments can be used, checking each time with an inch-pound torque checking tool. Stop when the bearing preload is within the acceptable range. If the proper preload range is exceeded, a new crush sleeve will be required before redoing the entire process. Crush sleeves are intended as one-time use and are not reusable. If the pinion assembly needs to be disassembled in the future, such as when installing a new pinion seal or yoke, a new crush sleeve will need to be installed. The dangers of attempting to reinstall a used crush sleeve are pinion bearing failure and greatly reduced pinion nut and yoke retention properties. The other method of setting pinion bearing preload is the solid spacer with adjusting shims. The installation is similar to the crush sleeve method, but requires disassembly to add or remove shim thickness until the proper bearing preload is set. The advantages of a solid spacer is that future disassembly to replace pinion seal, yoke, or bearings can reuse the same spacer and shim thickness. With new bearings, Ford 9-inch preload should be 18 to 26 inch-pounds. Once the proper bearing preload is set, fit the rubber O-ring into the small groove in the pinion support collar and apply some lubrication. The pinion depth shims have a 5 bolt hole pattern that matches orientation with the pinion support and third member case mounting area. To ensure a good and lasting seal between the third member and pinion support, the O-ring seal needs to stay in its groove and not get pinched. A good technique is to slowly tighten the pinion support bolts to the carrier with a hand ratchet while visually checking that the seal is recessing into the third member properly. Apply some lubrication to the differential side bearings and races, then fit the differential case assembly into the third member. Install the threaded side adjusters. Install the bearing main caps onto their appropriate side and orientation, which should match up with the markings made earlier. The threaded side adjusters should be checked to ensure they installed properly in their threads. Adjusters are seated when the main caps click into place and do not rock back and forth. If these are not threaded properly, it will cause damage to the case, bearing caps, and adjusters. Torque the main caps firmly. Heavy or precise torquing is not required during this step. Check and adjust the ring gear backlash. Backlash is the amount of free movement of the ring gear teeth from the pinion gear teeth. Gear manufacturers have a backlash range that their gear should be set within. This particular ring gear backlash range is from 8 to 10 thousandths. Tighten or loosen both threaded side adjusters to move the differential case assembly with the ring gear closer to or further away from the pinion gear. Once backlash has been set, brush 3 to 4 ring gear teeth with gear marking compound. Run the marked teeth vigorously so they mesh and contact the pinion gear teeth. After a few passes, read the contact pattern. Patterns that are too deep will look arched at the tip of the ring gear tooth on the drive side, but abruptly cut off near the root of the tooth. This means the pinion needs to be reshimmed slightly away from the ring gear. Reshim, reset the backlash, and recheck the pattern until it looks correct. Patterns that are too shallow look arched towards the bottom root, but abruptly cut off near the tip of the tooth. This means the pinion needs to be reshimmed slightly closer to the ring gear. Reshim, reset the backlash, and recheck the pattern until it looks correct. A proper contact pattern should be relatively centered between the tip and root of the drive side of the ring gear tooth, with some curve to both ends of the pattern, roughly similar to a football or oval shape. Having a good pattern will reduce gear noise and lengthen the life of the setup. Once a proper contact pattern is achieved, it's time for final assembly. Add some additional torque equally to the threaded side adjusters. A hole or two, or roughly 15 to 25 degrees, is usually enough to set adequate side bearing preload. Return the side adjuster lock clips into place. If they don't align perfectly with an opening in the adjuster nuts, tighten the nuts, never loosen them. Final torque the main cap bolts to 100 foot-pounds. Final torque the pinion support bolts to 45 to 50 foot-pounds. Recheck the backlash and pattern one more time. If everything still looks, sounds, and feels good, the 9-inch forward third member is ready to be bolted into its final home. If this helped your project, give us a like. Looking for further clarification on a step? Drop questions in the comments below. Need a second opinion on a build? Confused about compatibilities with a specific vehicle? Call us at 800-507-4327 or email tech@nationaldrivetrain.com for help from our experienced drivetrain and chassis technicians. Make sure to visit our webpage, nationaldrivetrain.com, for quality parts and components for your next project.